All right, in this problem we're going to do the infamous SAFE problem in your eLab. I'm going to try to do an explanation of this without solving the problem, so you're going to have to put in numbers and try to figure out the answer for yourself. So what we have is we have a safe that rolls down an incline and then rolls onto a flat surface. And the incline and the surface are made of the same material, so mu is the same on either surface. And mu they gave us is 0.1. And the incline here that it comes down is actually 5 meters long. So we can draw an FBD. This is a certain angle. I think it's 25 degrees. I'm not sure about that, actually. I think that's what I just remember. So there's an angle here. And we could draw an FBD on this incline for the ramp, for the object, and figure out what the acceleration is down the inclined plane, because there is going to be acceleration. That's what the problem says. But we've done that several times. You should review your notes, and you should remember that the acceleration down a frictioned inclined plane is g sine theta minus mu g cosine theta. So what that means is we can figure out the acceleration very easily with the angle and mu down this inclined plane. If we have an acceleration and we know the initial velocity up here, we're assuming is 0, we know the distance is 5 meters, we should be able to figure out the final velocity down here. So you should be able to do that. Vf squared equals vi squared, which is 0, 2 a d, and d is 5 meters, and the a you've already figured out from this equation. So we're going to do that first part of the problem to figure out this final velocity right here. Then what we're trying to do is we're trying to figure out if the safe rolls down the inclined plane, how far will it roll on this flat surface? How far is this distance right here before it'll come to a stop? So the final velocity at the bottom of this incline, which you'll have right here, will now be considered to be the initial velocity for the second part of our problem. Final velocity over here is 0. And I want to try to figure out what is distance. What is the distance here? And you'll see we're still going to be able to use this equation. Final velocity is 0. Initial velocity will be something though, so we're going to have to put that in. Vf squared equals vi squared plus 2ad, and we're going to solve for the displacement. But to do that, we need the acceleration. So we actually would have to make a new FBD of this object, the safe, on the flat surface. And if we do that, well, it's kind of interesting. We have the weight working down. We have normal force working up. The object is going to the right, but there is no force causing it to go to the right now. That force has all been expended, and now it's just slowing down. So there is force, though, going to the left, which would be friction. So if you look at this FBD, there is a net force, right? The net force, F net, would equal any force going in the direction of motion, which we just said there is none. So zero force going to the right, minus any force going back to the left, which of course would be friction. So what we have is F net is ma equals a negative, friction is mu normal force, right? And so we have ma equals a negative mu. In this case, the normal force would be the weight, which would be m times g. Masses will cancel out, and the acceleration rate of the box going on the horizontal surface, the equation for the acceleration, would actually be negative mu g. So gravity is 9.81, mu is 0.1, so technically acceleration, I guess I did figure out something for you here, would be a negative 0.981, would be my acceleration rate as it's going from here along here. So now if I know my acceleration rate, I can put that in for this. I know my initial velocity is whatever I got at the bottom of this incline. Final velocity is 0, and I can solve for my displacement on how far over we made it. And I think the problem says to go ahead and put that into 3 sig figs or something like that. So make sure you read the problem and see how many sig figs you're supposed to put your final answer in. So I know I didn't solve all the question out for you with the numbers, but that should be more than enough for you to be able to get to the end of the problem.